We now discuss the solution of a problem from the section complex analysis, and the problem is on the locus of a point, and this question has appeared in CSIR National Eligibility Test held on 30th November 2020, and it is from the section C. The problem is, fix a positive real number C. Consider the locus of all points Z belongs to the set of complex numbers C such that modulus of Z minus I by Z plus I is equal to C, where C is a constant. Which of the following statements are true? We are given four options. Option 1. If C is greater than 1, the locus is a circle centered on the imaginary axis. Option 2. If C less than 1, the locus is a circle centered on the real axis. Option 3. If C is equal to 1, the locus is a straight line parallel to the imaginary axis. Option 4. If C is equal to 1, the locus is a straight line not passing through the origin. Let's now discuss the solution of the problem in detail. We are given that C is a fixed positive real number and required to find the locus of all points Z belongs to C, the set of complex numbers, such that modulus of Z minus I by modulus of Z minus I by Z plus I. Z minus I by Z plus I is inside the modulus is equal to C, where C is a constant. Now, modulus of Z minus I by Z plus I is equal to C will imply modulus of Z minus I is equal to C times modulus of Z plus I, where Z is a complex number, X plus IY, where X and Y are real numbers. Writing X plus IY for Z and simplifying, we get mod of X plus I times Y minus 1, yes, is equal to C times modulus of X plus I times Y plus 1. Squaring on both sides, we get this, and we know that the modulus of A plus IB whole square is equal to A square plus B square. Therefore, this will give you X square plus Y minus 1 whole square is equal to C square times X square plus Y plus 1 whole square. Now, send these terms on the left hand side to the right hand side and simplify. We will get the following. That is C square minus 1 into X square plus C square minus 1 into Y square plus 2Y times C square plus 1 plus C square minus 1 is equal to 0. Let's call this equation as 1. Let's continue in the next slide. So that is our equation 1. Let's consider the case 1. Let C not equal to 1. Yes. Then the above equation becomes, when C not equal to 1, and divide throughout by C square minus 1 in that case. Then that will be X square plus Y square plus 2 times C square plus 1 by C square minus 1 into Y plus 1 is equal to 0. And what is this? This is the equation of a circle. So, thus, the locus of Z is a circle centered at minus G, minus F. That is minus G. That is minus the coefficient of 2x. The coefficient of 2x is 0. So, minus F is the coefficient of 2y. So, minus C square plus 1 by C square minus 1. And what is this? It is a point on the y-axis, that is the imaginary axis. Therefore, the locus is a circle centered on the imaginary axis. Therefore, if C greater than 1, certainly C not equal to 1, therefore this conclusion is valid. the locus is a circle centered on the imaginary axis. And if c less than 1, that is 0 less than c less than 1, the locus is also the same circle centered on the imaginary axis. So, what are our options? Our option 1 says, if c greater than 1, the locus is a circle centered on the imaginary axis. That is our conclusion. And option 2 says the locus is a circle centered on the real axis, which is not true because it is centered on the imaginary axis. Therefore, the option 1 is true and the option 2 is not true. Therefore, the option 1 is true and the option 2 is not true. Let's continue the discussion in the next slide. We consider that is our equation 1, we consider the second case. Let c is equal to 1. When c is equal to 1, c square minus 1 is equal to 0, then the above equation becomes 4y is equal to 0. C is 1, c square plus 1 is 2, 2 times 2y is 4y is equal to 0. This will imply y is equal to 0. Y is equal to x, y is equal to 0 means it is the x-axis, that is the real axis. Thus, the locus of z is the real axis. And therefore, the locus is a straight line not parallel to the imaginary axis because it is a real axis. And the locus is a straight line passing through the origin because it is a real axis. And the options 3 and 4 says, under 3 it says the locus is a straight line parallel to the imaginary axis, and our conclusion is not parallel to the imaginary axis. Option 4 says the straight line not passing through the origin, but it is a real axis, it passes through the origin. So, option 3 and 4 are not true. Therefore, our final answer is option 1 is true. That is the solution of the problem from the section complex analysis, and the problem is based on the concept of the locus of a point in the complex plane. I hope that you have understood the solution of this problem, and I wish you all the best. Thank you.